this is lesson 1. And we're going to talk about properties of real numbers. Okay, so in your book, you'll see these warm-up exercises. Every once in a while, we'll do some of those, but they're really good prep, kind of like what geometry was. Like those warm-ups had to do with what's to come and just making sure you had enough. We're going to get right into it because I don't know that we'll have time, but you can always go back and look at those warm-up exercises if you want to. So we're going to talk about some new concepts. Okay, so let me give you some definitions. So real numbers, and believe it or not, there are numbers that aren't real. We're going to talk about those later. So real numbers, basically a set of numbers consisting of several subsets of numbers. So it's hard to define real numbers. It's easier to define real numbers by their subsets. Okay? Rational numbers. And irrational numbers. So rational numbers, basically, there's a word in there, ratio. So rational numbers is basically anytime you can write a number as a fraction, then it's a rational number. Okay, so you've got rational numbers. So a ratio of two counting numbers. So 1/2, 1/4, even 1/3, even though it's a repeating decimal, it's still a rational number. So irrational numbers are ones you can't write as a fraction. Okay, another way to define it is if you were to write this out, it would be a never-ending, never repeating decimal. So it's impossible to write out using digits an irrational number. Okay? A good example is pi, 3.14159, and then it keeps going. And it never repeats. There's never a pattern. People devote their lives to try to find a pattern. Stay away from those people. Okay? So there's no pattern, there's no repetition, it never ends. Okay? So those are irrational numbers. And then you've got integers. So all these integers is a subset of rational numbers. Remember, rational numbers are a subset of real numbers. Integers are a subset of rational numbers. Yeah, you can write them as a fraction if you want, but they're just whole numbers and their opposites. So write that down, whole numbers and their opposites. Okay, so I can express this in set notation by an ellipses on the front end, and then like a -3, -2, -1, 0, 1, 2, 3, and then an ellipses on that end. So remember, those ellipses say it goes on forever in that pattern. So see how these are all the whole numbers and their opposites. Opposites means positive or negative. Opposite of a positive is a negative, opposite of a negative is a positive. Okay, then after integers, you got whole numbers. Basically, those are positive integers, but with zeros. So 0 is not positive or negative, it's just 0. And then the next one down is natural numbers. But see how these guys, see, all the whole numbers are still integers, right? Integers are not just negative numbers. They're all positive numbers in their opposites, all positive whole numbers in their opposites. Natural numbers are just like whole numbers, but without the whole, without the 0. It's a good way to remember what whole numbers are that have a hole in it, 0. So I can draw a little Venn diagram. So if this is like your rational numbers here, rational, and then inside the rational there's another one, there's integers. Inside the integers there's whole numbers. Inside the whole numbers there's counting or natural numbers. Okay, so some examples that are in rational numbers are like 3/5, 1.3 repeating, 1.75, all these, even negative 3/5, and negative 1.3 repeating. Integers are just all the whole numbers and their opposites, but see how this is still a rational number. You can write -5 as a fraction. How do you write -5 as a fraction?
-5/1.
Yeah, you just throw it over 1. You can write any number as any whole number or integer as a fraction, just throw it over 1. Okay? And this is even an integer. An integer are all the whole numbers and their opposites. So 5 is still an integer. Actually, this 5 should be over here. The only thing in this circle that's not in the natural number circle is that 0. That's it. Okay? So if you're a visual person, that might be helpful, but sometimes that's confusing to people. And then there's this whole other circle over here, which is the irrational circle, the irrats. That's where we see pi, where we see the constant e. And we see a bunch of, anytime you try to take the square root of anything that is not square rootable, like square root of 10, you can't take the square root of 10. Anytime you try to find the square root of anything that's not square rootable, it's an irrational number. Okay? It's a never-ending, never-repeating decimal. So on a test, if it says, name the irrational numbers, they're never going to write something out with decimals. It's either going to be a symbol, like pi or e, or the square root of something that's not square rootable. But sometimes they might trick you and write 2 pi over pi. What's 2 pi over pi? 2. So that's still a rational number because the pi's cancel. Or this would be more specific because it's just in the rational circle. The pi's cancel and it's just 2/5, right? Okay, so this is review, but it's not something we spent a lot of time on in Algebra 1. You work with these numbers all year, but you don't really name them and classify them as much as you need to. But anyway, okay, so in your homework, you're just going to be given some numbers. Here's another one, negative square root of 5. You can have negative irrational numbers. The negative doesn't make it rational or irrational. So there's no such thing as irrational integers or irrational whole numbers or irrational anything else. It's just irrational numbers. They're just a group by themselves. Okay, so far so good? All right, I'm going to erase this. and start another page. Okay, we're going to talk about properties. This is review. Properties of addition and multiplication. Now, the reason we don't include subtraction and division is because subtraction and division is dumb. So, a lot of properties don't apply to subtraction and addition. So, a lot of times we'll change subtraction problems to addition problems. You can do that. Chicken scratch. Remember, you change it to addition and then change the sign of the next number. Multiplications, a lot of times we'll change division problems to multiplication problems. 5 divided by 3 is the same thing as 5 times 1/3. Copy.flop. All right, so here's properties. This is called the closure property. This is a new one. This just says A plus B, and this is if, let me just rewrite that, sorry. If A, B, and C are real numbers, then A plus B is also a real number, and A times B is a real number. Okay? So if you have two real numbers and you add them together, the result is going to be a real number. If you have two real numbers and you multiply them together, the result is going to be a real number. All right, here's some familiar properties. Commutative. You guys remember what commutative is? What's commutative property? A plus B equals B plus A. You can switch the order and it doesn't matter. Can you do that with subtraction? No. But you can with multiplication. AB equals BA, right? 3 times 5 equals 5 times 3. All right, this is another one that's a little harder to remember. Associative. You guys remember what associative property is? This is how numbers are associated with each other. So if A plus B are hanging out, they don't associate with C. But A plus B plus C equals A plus B plus C. Okay? So it doesn't matter what you add first, you'll come up with the same result. Same thing with multiplication. AB times C equals A times BC. Hopefully you can read that. You can probably guess what it is anyway. So associative property is where you put the parentheses. When you have 3 or more things you're adding or multiplying. Doesn't matter where you put the parentheses. If it's all addition or all multiplication. Like it doesn't work with addition and multiplication in the same problem. Okay? So this is kind of a combination of two of these properties. This is called distributive. So same thing, same conditions. And A times B plus C equals A times B plus A times C. You guys did this a lot in Algebra 1. You're going to do this a lot in Algebra 2. Okay? Sometimes it looks foreign when it's all letters. We don't know what's going on. But this should look pretty familiar. Parentheses are like the enemy of simplification, simplifying. So that's one of the ways that we get rid of parentheses is by distributing. Okay, so in your homework, you're going to get examples and you're going to be asked to identify the property. Okay? So what property is this? 3 times 8 equals 8 times 3, which all equals 24. What property is displayed there? Commutative, that's right. All right, what about this guy? 5 times 7 plus 11 equals 35 plus 55, which equals 90. What property is that? Distributive. We're distributing the 5 to the 7 and to the 11. Okay? Now, sometimes this is an easier way to do this problem, but I'm just going to follow the order of operations. 5 times 18 is 90. So it doesn't matter what way you do it. The distributive property says you can do it both ways. But here's a little trick. 22 times 15. That's kind of hard to do. You know what I do? 22 times 10 and 22 times 5. What's 22 times 10? 220. What's half of 220? 110. So then you get 330. So multiplying by 15, I'm using the distributive property. I'm separating that 15 into a 10 plus 5, multiplying by 10 first and then by 5. Multiplying by 5 is pretty easy. You just multiply by 10 and cut it in half. Okay? That's the distributive property. All right, and then there's example 3. You're going to be doing, actually using these properties. Well, you use these properties in 7th grade, okay? So we're not going to go over those. Any questions with these properties? So the only real new one is that closure property. That's just talking about the set of real numbers. So whenever you do whenever you add or multiply in the set of real numbers, you stay in the set of real numbers. Okay? All right. So here's a couple more. Couple more properties. And these, these are things that we know, but we just don't really classify them much. But this is the addition or additive property of identity, or identity property of addition. A plus 0 equals A. Okay? And I'm going to say, and also multiplicative. Multiplicative and additive property. Also, it's not times 0, it's times 1, right? So whenever you multiply anything by 1, it stays the same. That's why we call it the identity property, because it maintains its identity. Okay? Here's a new one. Well, not really. So this is called the inverse property. Is this A plus negative A equals 0. So basically the inverse property is, what do you have to add to something to get to the identity? Well, what do you have to add to something to get to the additive identity, which is 0? So this is the additive identity. And this is the multiplicative identity. So what do you have to multiply by something to get to 1? What do you have to multiply by a number to get 1? So any number times 1 is itself, not 1. Not a negative. 5 times negative 5 is negative 25.
What was the question again?
What do you have to multiply by a number to get 1 is the answer?
1.
Well, let's go
1 over
backwards.
A.
Right.
1 over A.
Let's go backwards. Answer divided by factor, or 1 over A. What's 5 times 1/5? 1. What's 6 times 1/6? Good. Okay. So basically, and what do you have to do here? Does this make anyone uncomfortable?
Yes.
Geometry. I've been uncomfortable.
Extremely
For
uncomfortable.
like, how long is this class? Okay.
We're halfway there.
By the way, we have to do a disclaimer. Do you remember our disclaimer? Geometry students?
What was the question? I keep not listening.
Whenever I see this, it makes me uncomfortable.
Why?
So I have to say that A can never equal 0. Okay? Because you can't have 0 in the denominator of a fraction. So that A just can't be 0. Okay? So basically, whenever you multiply a number by its flip, that's called a reciprocal, or multiplicative inverse, is how the cool kids are saying it. Multiplicative inverse, then you get 1. All right? Unless that number, A, is 0. Okay? So the only number that doesn't have a multiplicative inverse or a reciprocal is 0. Good, good?
Sure.
Maybe.
All right. So here's some examples. And this is the end of lesson 1. So we'll move on to lesson 2 after this. Here's example 4. I want you to find the additive inverse of negative 7a. What is the additive inverse of negative 7a? It's negative 7 times a, or negative 7a. Don't overthink it. 7a, you just negate it, okay? You just, if it's negative, you make it positive. If it's positive, you make it negative. Because no matter what a is, let's say a is 3, negative, that would be negative 21. What's the opposite of negative 21? Positive 21. So all you have to do is change the sign. That's the additive inverse. That's nice. Okay, let's find the multiplicative inverse of this number. I can't read it, but I don't think it matters, does it? 5n over 12p. What's the multiplicative inverse?
12p over 5n.
Okay, 12p over 5n. Okay, and if you wanted to, you could say n can't be 0 or p can't be 0, because that would make the denominator 0, but you're good.
Flack math! Give me some math and I'll give you some flack. Flack math!